outside thing was y equals something to the 1/3, right? So what is the derivative of u to the 1/3? 1/3 u to the, I agree, negative 2/3. Well, instead of hesitation in his voice, but yes, 1/3 minus 1 is negative 2/3. Okay, so we have x squared plus 2x raised to the 1/3. So what do we do now? Yeah, basically x squared plus 2x is in the place of u, so it's 1/3 and x squared plus 2x raised to the negative 2/3. Am I done? No. That's the derivative of the outside. We kept the inside, and now we're going to do derivative of the inside. What's the derivative of the inside? 2x plus 2. Now, that is one appropriate answer. Okay. There's some other appropriate answers I want to talk about. What do you notice about 2x plus 2? Again, there is a GCF of 2, and what's already out front? A 1/3. So you could do it 2 times 1/3 out front. If that's the case, 2 times 1/3 is 2/3. And then you can have times x squared plus 2x to the negative 2/3 times x plus 1. That is an acceptable answer. Now, there's another way that we could also clean this up that I want to just mention. What's the other big cleanup thing I could do? What can I do with the negative exponent? Okay, put it under 1, so put it in the denominator, right? So the idea then is 2/3 is already a fraction, right? So the 2/3, 2 is on the top of the fraction, 3 is the bottom of the fraction. X squared plus 2x is a negative 2/3. Can be written as a positive 2/3 by putting that expression in the denominator. So I could put x squared plus 2x to the positive 2/3. And then where's the x plus 1 go? Up at the top. Well, again, they're just equivalent expressions. And really want to get fancy, in that x squared plus 2x is an x you can factor out. It has to be an x to the 2/3. Again, that's getting a little fancy for my face, but not to say you can see something like that by the end of the school year, so I don't remember necessarily, but okay, we get on example 2. Let's try example 3 then. Stop needing a question. Okay, what do you see on example 3? Okay, my outside function is the natural log of something, right? So with the help, you can think the natural log of u. What's the derivative of the natural log of u? So over here in my side notes, y prime is 1 over u. Right, so let's go back into the actual function. G prime of x. The derivative of the natural log of x squared minus 42. So the derivative of the natural log of something is 1 over something times the derivative of something. What's the derivative of my something? 2x. Okay? How can I rewrite this? Clean up. Yeah, you can put the 2x on top, and it's 2x over x squared minus 42. We've got like 5 more to do, so it's kind of, they call it a variety here. The more you see, the more you kind of get adjusted to it. Then you might have this crazy thing called work time. I know you guys don't know what to do with work time in calculus, but yes, remind me. Example 4. F of t equals sine of t to the third minus 15 find f prime of t. What's the outside function we're taking the derivative of? Sine. Okay? So sine of something, so sine of u. What is the derivative of sine of u while I'm thinking about it? Sine of something is cosine of something. Okay? So we're trying to find f prime of t. Derivative of sine of t cubed minus 15. So derivative of sine of that something is going to be cosine of that something, so keeping t cubed minus 15 the same, times, right, the derivative of something. So the derivative of t cubed minus 15, which is 3t squared. The only thing you can really do there is do a little bit of cleanup, and the only cleanup I can really do is put the 3t squared out front. It's a little more natural to have the 3t squared out front, so it doesn't kind of blur in with what's inside of cosine. I'm not saying it's required, it's just a little more natural. So I can rewrite this as 3t squared times cosine of t cubed minus 15. Okay. Example 5. Y equals sine cubed x. Lots of this one. Okay. This is equivalent as saying sine x to the power of 3. Yes, and that is a good way to think about it. Sine cubed x is the same as saying sine x raised to the power of 3. So if I rewrite it like that, what's my outside function? Yeah, u to the third. In other words, it's something raised to the third. So that is what you should be thinking there. So what's the derivative of u to the third? 3u squared. So the derivative of sine x to the third, which actually they ask us to write it as dy dx this time. Change it up. Remember, y prime is a way of saying derivative. Dy dx is a way of saying derivative. So the derivative of sine x to the third is 3 sine x squared. So derivative of something to the third is 3 something to the second times derivative of something. So derivative of sine is cosine. No. We're going to take derivatives in integrals. We go plus c, not derivatives. Now, cleanup wise, you could rewrite this. I kept it as the squared on the outside, but realized that squared could go back and go with sine x. And I'm not saying you have to again, but if I was doing this, I'd rewrite it as 3 sine squared x cosine x. Do be careful, you keep that sign as a sign as you go about it, right? You did hear a slip up where trying to take the derivative sign, make it cosine right away. But you gotta keep the inside at first and then take the derivative later. Okay, example 6. Working our way right through these. What do you know in example 6? Okay, cosine u. So overall, we're taking the derivative of cosine of something. What's the derivative of cosine? Negative sine. Okay, so dy dx. So now we've got the cosine of e to the x. Derivative of cosine of something, negative sine of something. And something is e to the x times derivative of something. What's the derivative of e to the x? E to the x. This is another one. Not required that you rewrite it, but I would rewrite it with that e to the x out front. Just a little more natural to have a coefficient type out front rather than after. So dy dx equals the negative e to the x sine e to the x. It's just kind of ugly to look at, isn't it? You've got 2 e to the x's in there.